Dear students, in this video I am going to solve numerical problems appeared in the year March 2019. Okay, let's have a look on the very first problem. In this problem, the radius of the circular plate here 5 centimeter, that can be written as 5 into 10 raised to minus 2 meter, because centi means 10 raised to minus 2. The separation between the two plate is 2 millimeter. It is 2 into 10 raised to minus 3 meter. We could write like this. Then applied voltage is 200 volt. We need to find out capacitance of the given capacitor and the energy stored in the capacitor whenever it is connected to 200 volt supply. Now we know that the capacitance of the parallel plate capacitor is given by epsilon naught A divided by D, where epsilon naught is the permittivity of the free space and A is the area of the plates and D is the distance between the two plates. That is nothing but separation between the two plates. This is equals to, here area via, we need to consider area of the circular plate. The area of the circular plate is given by pi r square. So we could write here epsilon naught pi r square divided by D. Now on substituting the values, that is the value of epsilon naught is 8.854 into 10 raised to minus 12, and here pi value is 3.142, and r square, here r means 5 into 10 raised to minus 2 whole square, divided by the separation between the two plates is 2 into 10 raised to minus 3. This is equals to, we know that 8.854 into 3.142 is 27.819 into 10 raised to minus 12 into 5 square means 25, 10 to the power of minus 2. When we do square, then you will get 10 to the power of minus 4 divided by 2 into 10 raised to minus 3. Now C is equals to 27.819 into 25, 695 into 10 raised to minus 10 to the power of minus 12, 10 to the power of minus 4, it will become 10 to the power of minus 6, 10 to the power of minus 16 divided by 2 into 10 raised to minus 3. And this is equals to, that is 695 divided by 2, that gives us 347.7, 347.7 into 10 to the power of minus 13. If you express your final answer to the one decimal place, so we will get C equals to 3.477 into 10 raised to minus 11. This is the capacitance of the given parallel plate capacitor. Now we need to find out one more parameter, that is the energy stored in the capacitor when it is connected to 200 volt supply. We know that the energy stored in the capacitor is equals to half CV square. Just now we got capacitance of this capacitor, that is 1 by 2 into 3.477 into 10 raised to minus 11 into here applied voltage is 200, make it square, 200 square. So now this is equals to 1 divided by 2 into 3.477 into 10 raised to minus 11, and 200 square is nothing but 4 into 20, that is they will become 4, so 10 to the power of 4 we can write. This is equals to 2 1 ja 2 2 ja, then 3.477 into 2, 3.477 into 2 is equals to how much? 2 1 ja 2 2 ja, 3.477 into 2, 6.954, 6.954 into 10 raised to minus 7. This is the energy stored in the capacitor, that is U equals to 6.954 into 10 raised to minus 7 joule. Let's move to the next question. Okay. In this problem, there are two resistances which are connected in series as well as parallel. When they are connected in series, and connected it to the external source of EMF 5 volt and internal resistance 0, we get a current of 2 ampere. 2 ampere. The same resistance, whenever we connect them in parallel to the same source, that is EMF is 5 volt and internal resistance 0, we get a current of 25 by 3 ampere. We need to find out these resistances, individual resistance. Let me consider them as R1 and R2, R1 and R2. So now let us find out R1 and R2. Okay, so here whenever we connect them in series, we know that the current in the circuit is equals to IS. Let me write the current in the series circuit is IS. This IS can be written as E divided by external resistance plus internal resistance. We know that the internal resistance of the given cell is 0, so we could write here E divided by R only. So let me write here R means RS, external resistance. They are connected in parallel. We can write E divided by RS. Now on rearranging, we will get that is RS is equals to, that is RS can be written as E divided by IS. Here E equals to how much? 5. I is equals to 2 ampere. This will be equals to, that is 2.5. Here RS is equals to 2.5. That is, we can write here RS is equals to 2.5. 2.5. This could be written as R1 plus R2 is equals to 2.5. Now coming to the parallel connection, here we know that IP, the current in the parallel circuit, is equals to E divided by RP plus internal resistance. Here internal resistance is 0, so we could write here E divided by RP. And rearranging, we will get RP equals to, that is RP is equals to E divided by IP. Here we know that E equals to 5 and IP equals to 25 by 3. So this is equals to, that is the 15 divided by 25. The 15 divided by 25 can be written as 3 by 5. This is what RP. We know that RP can be written as RP, it is R1 R2 divided by R1 plus R2. So whenever the two resistors are connected in parallel, then the effective resistance is equals to R1 R2 divided by R1 plus R2. This is equals to 3 by 5. Just now we have seen R1 plus R2 is equals to 2.5. Let me write here R1 plus R2 equals to 2.5. When you write here R1 plus R2 equals to 2.5, what would happen? Let me write here, in place of R1 plus R2, I could write 2.5. Let me write here 2.5. So on simplifying this, we will get R1 R2 is equals to 2.5. Will come this side. Then what will happen? That is 3 divided by 5 into 2.5. 2.5 1 jar, 2.5 2 jar, and 3 by 2. 3 by 2 is nothing but 1.5. This is R1 R2. So here we have R1 plus R2. To find out the individual resistances, we need R1 minus R2 also. Here we have sum. We need to get the difference also. To get the difference, we need to use a relation, that is A minus B whole square. That is A minus B whole square equals to A plus B whole square minus 4AB. By using this relation, we can get R1 minus R2 also. Okay. So in the case of capacitors or in the case of resistors, this formula is same. That is A minus B whole square equals to A plus B whole square minus 4AB. This we can use to find out the individual resistances or individual capacitor like this. So let me write now R1 minus R2 whole square is equals to R1 plus R2 whole square minus 4 R1 and R2. In place of A, I have written R1. In place of B, I have written R2. Now we can write here R1 minus R2 whole square is equals to, we know that R1 plus R2 is equals to 2.5. That is 2.5 whole square plus 4 into R1 R2. Here R1 into R2 is 1.5. This is equals to 2.5 whole square is 6.25 and 4 into 1.5 is, 4 into 1.5 is, this is minus. This minus it is, it's 1, 6. So this will become how much? 0.25. This is what? R1 minus R2 whole square. What we want? We want R1 minus R2. So R1 minus R2 is equals to the square root of 0.25. The square root of 0.25 is 0.5. This is what? R1 minus R2. Let me consider this is equation number 2 and this is equation number 1. I'm solving these two, R1 and R2. These two equations will get R1 and R2. Let me write here R1. Let me write here the equation number 1, that is R1 plus R2 equals to 2.5. This is equation number 1. I'm solving these two. Here, this and this get cancelled. So I'm adding these two. These will get cancelled and we'll get 2R1 is equals to 3. So R1 equals to how much? That is 1.5 ohm. This R1 equals to 1.5. So I'm substituting this in any one of the formula, that is R1 minus R2 or R1 plus R2 equals to 2.5, we'll get R2 also. So let me write here R1 plus R2 equals to how much? 2.5 here. Now I'm substituting R1 value, that is 1.5 plus R2 equals to 2.5, we'll get R2. That is R2 equals to 2.5 minus 1.5 is 1. That is R2 equals to 1 ohm. That is R1 equals to 1.5 ohm and R2 equals to 1 ohm. Okay, in this way we can solve this type of problems. Okay, let me move to the next question. In this problem, a conductor of length 3 meter moving in the magnetic field of magnetic strength 100 Tesla and which covers a distance of 70 meter in 5 seconds. And the plane of the motion of the conductor having an angle 30 degree with the direction of the magnetic field. We need to find out induced EMF. That induced EMF is called as motional EMF because we know that the motional EMF is the EMF which is induced in the conductor moving in the magnetic field. Okay, the conductor magnetic field move ಆಗ್ತಿದೆ ಅಂದ್ರೆ ಆ ಕಂಡಕ್ಟರ್ ಅಲ್ಲಿ ಇಂಡ್ಯೂಸ್ ಆಗಿರತಕ್ಕಂತ EMF ನ ನಾವು motional EMF ಅಂತ ಕರಿತೀವಿ. The motional EMF is given by the expression, that is the EMF. Motional EMF is equals to BLV sin theta. This is the expression for motional EMF. Here we have magnetic field, that is 100. Let me write here B, L, and V is nothing but distance traveled by the conductor in the time interval T. This we can write. Now just you substitute the given data, we'll get the value of induced EMF. That is equals to P equals to here 100. And length of the conductor is 3 meter and distance covered by the conductor in the magnetic field is 70 meter divided by the time is 5 and sine the angle 30 degree. So we know that is EMF equals to 300 into 300 into 70 divided by 5, that is equals to 1 4, that is 14, and sine 30 value is 1 by 2. So this can be done as that is 2 1 ja 2 7 ja. So it will become E equals to 2100 volt. This is the EMF induced in the conductor. Okay, let's move to the next question. In this problem, wavelength of the light used is 5000 angstrom. This can be written as 5 into 10 raised to minus 7 meter because here 1 angstrom means 10 to the power of minus 10 and here we have 3 zeros, that is nothing but 10 to the power of 3, 10 to the power of minus 10 into 10 to the power of plus 3, 10 to the power of minus 10 into 10 to the power of plus 3 equals to 10 to the power of minus 7. This is equals to, now here you can see distance between the two plates. We have here distance between the two plates, that 2 millimeter. 2 milli means 10 raised to minus 3 meter and the distance between the screen and the slits is capital D, that is equals to 1 meter. And here we need to find out fringe width as well as the distance of the 7th dark fringe. So which fringe? Dark fringe from the central fringe we need to find out. So distance of the 7th dark fringe from the central fringe. So let's find out first fringe width. That is, we know that the fringe width expression beta equals to lambda capital D divided by small d. Just to substitute the given values, we'll get the fringe width. That is lambda equals to 5 into 10 raised to minus 7 into distance between the screen and the slits is 1 meter, and the separation between the slits is 2 into 10 raised to minus 3. This can be written as, that is beta equals to 5 by 2, that is 2.5 into 10 to the power of minus 7 divided by 10 to the power of minus 3 is 10 to the power of minus 4 meter. This is 2.5 into 10 to the power of minus 4 meter. Or else we can write this is equals to 0.25 into 10 to the power of minus 3 meter. That is nothing but 0.25 millimeter. This is the fringe width value. Or else we can write like this, 2.5 into 10 raised to minus 4 meter. Okay, now let me find out the distance of the 7th dark fringe from the center fringe. So we have an expression for the distance of the nth dark fringe from the center fringe. Let me write here the distance of the nth dark fringe from the central fringe is 2n minus 1 of lambda d divided by 2d. This is the formula for distance of the dark fringe, distance of the nth dark fringe from the central fringe. Suppose if it is bright fringe, then the formula would be like this. Distance of the bright fringe from the central fringe is n lambda d divided by d. That is, whenever we get a bright fringe, there will be constructive interference. Because of that reason, we will get the bright fringe. So we are getting n lambda divided by d, integral multiple of lambda. But whenever we get a dark fringe, that means that there is a destructive interference. What is the condition for the destructive interference? That is odd multiple of lambda by 2. So we can get odd multiple of lambda by 2. 2n minus 1 is odd multiple lambda by 2. So okay, 2n minus 1 lambda by 2 is the odd multiple. So we will get here xn, that is distance of the nth dark fringe from the central fringe is 2n minus 1 into lambda d divided by 2d. Suppose if they ask you to find out distance of the nth bright fringe from the central fringe, at that time you need to use n lambda divided by d. But in the question we can see the dark fringe, so we can have here 7th fringe we are finding. This is 2 into, here n is 7th fringe, minus 1 into lambda equals to how much here? 5 into 10 to the power of minus 7. Capital D is 1 meter divided by 2 into the distance between the two slits is 2 into 10 raised to minus 3. This is equals to, now 14 minus 1, 13 into 5 into 10 raised to minus 7 divided by 4 into 10 to the power of minus 3. And here we have 13 into 5, that is 65 into 10 raised to minus 7. Sorry, 10 to the power of minus 7 divided by 10 to the power of minus 3. This will become 10 to the power of minus 4 divided by 4. This is equals to 16.25 into 10 raised to minus 4 meter. So you express your answer to the one decimal place, we will get 1.625 into 10 raised to minus 3 meter. That is, distance of the 7th dark fringe from the central fringe is 1.625 millimeter. Or else you can write 1.625 into 10 raised to minus 3 meter. Okay. Let's go to the next question. Half-life of uranium-238 undergoing alpha decay is 4.5 into 10 raised to 9 years. What is the activity of 1 gram of uranium-238 sample? In this problem, uranium-238, that is uranium-238 having half-life period, that is half-life period of the uranium-238 is how much? 4.5 into 10 raised to 9 years. And our aim is to find out activity of 1 gram of uranium-238 substance. So before going to find out that, let me express this in SI unit, that is in second. We are having here 4.5 into 10 raised to 9. Here in 1 year, how many seconds are there? 3.1536 into 10 to the power of 7 seconds are. This is what number of seconds present in 1 year. How can you calculate this? So 1 year, in 1 year is equal, in 1 year How many days are there? 365 days. In one day, how many hours are there? 24 hours. In 1 hour, 60 minutes, 60 seconds. So this gives us 3.1536 into 10 raised to 17. So this is what the number of seconds present in 1 year. Okay. This you need to keep in mind. Directly we can write 3.1536 into 10 raised to 7. Now, on calculating this, we get the half-life period of this radioactive substance equals to 4.5 into 3.1536. 14.19 into 10 power of 16 second. And this can be written as 1.419 into 10 power of 17. Okay, and this is very nearly equals, that is 1.42. I could write directly, that is 1.42 into 10 raised to 17 seconds. Now we need to find out the activity of 1 gram of radioactive substance. So we know that the activity of the radioactive substance is equals to lambda n. So now to find out activity of radioactive substance, we need to get lambda, that is decay constant, as well as number of atoms present in 1 gram of the radioactive substance. So now let me find out first lambda. After that, let me find out number of atoms present in the radioactive substance. So we have a relationship between lambda and half-life. What is that relation? We know half-life is equals to 0.693 divided by lambda. So this is the expression for half-life of radioactive substance. Now lambda can be written as, so lambda is equals to 0.693 divided by T of is equals to how much here? 1.42 into 10 to the power 17. And this is equals to 0.693 divided by 1.42 is equals to 0.488 into 10 to the power minus 17 and minus 17 second. This can be expressed to one decimal place, that is 4.88 into 10 to the power minus 18 per second. Okay, this is what decay constant, 4.88 into 10 to the power minus 18 second. Okay, this is what. Now let me find out the number of atoms present in 1 gram of substance. So here we know that 238 gram, that is 238 gram of uranium substance consisting of how many number of atoms? 6.023 into 10 to the power 23 atoms. This is Avogadro number. Okay, 238 gram of uranium consisting of these many number of atoms, and 1 gram of the uranium substance consisting of how many number of atoms? Let me consider n. On cross multiplying, we will get n is equals to 6.023 into 10 to the power 23 into 1 divided by 238. Okay, 6.023 divided by 238 is equals to 0.0253 into 10 to the power 23. This is equals to, that is n is equals to, here let me express to the one decimal place, 2.53 into 10 to the power 21 atoms. These many number of atoms are present in 1 gram of uranium substance. Now we can calculate activity of radioactive substance. Activity of radioactive substance is given by lambda n. So let me substitute now. Activity is equals to lambda here. How much lambda we have here? 4.88 into 10 to the power minus 18 into number of atoms present in 1 gram of uranium substance is 2.53 into 10 to the power 21. So this is equals to, and simply we will get 12.34 into 10 to the power 3, and this is equals to, we can write 1.234 into 10 to the power 4 backward. Okay. This is the activity of 1 gram of radioactive substance. Okay, thank you, thanks for watching.